Find the resonant frequency for the following circuit. As I mentioned, you cannot use 1 over 2 pi square root of LC to find F0 for the circuit, because this is valid only for the RLC series circuit and RLC parallel circuit. But here I have a combination of RLC circuits, so I cannot use this, or RLC elements, I cannot use that. Another important point: never ever transfer the circuit by using the source transformation theorem. Keep it as it is, because when you transfer the circuit, the characteristics of the circuit is going to change. So do not use the source transformation theorem and transfer the circuit. Now I forgot to write down here, this is 4 Henry. Now convert the given circuit into frequency domain. So this is 1 over j omega 0.5. Another important point, I saw many times, we know that 1 over 0.5 equal to 2. I saw many times students were taking this as 2 in, it's supposed to be 2 over j omega, but I saw students were taking this as minus j2 omega. You cannot take the omega to the numerator. Omega is going to stay in the denominator all the time. Okay, so this is wrong. The right answer is 2 over j omega. As I mentioned, I'll keep j and omega together as much as possible. So this is going to be 4 over j omega. This is 4j omega 6. Now I can clearly see these two are parallel. My apology, those two are in series. 6 ohms and 2 over j omega, they are in series. How do I know? I mean, as long as same current passing through them, they are in series. So this series combination is parallel with j4 omega. So let me label this as zx, label this as zy. So zx and zy, these two are in parallel. Zx parallel with zy. What is our goal? Our goal is find the z total. Once you have the z total, find the imaginary part and make it equal to 0. Okay, so zx and zy are in parallel. So 4j4 omega times 6 plus 2 over j omega over j4 omega plus 6 plus 2j omega. Okay, I think it's a good idea to simplify this first. 6 plus 2j omega, 2 over j omega. I'm going to simplify this first. This is going to be 6j omega plus 2 over j omega. Okay, so this value is j4 omega times 6j omega plus 2 over j omega divided by j4 omega plus j6 omega plus 2 over j omega. Okay, now another important point is, do not cancel this j omega here and j omega there, because I have j omega in the denominator too. These two usually get cancelled out, the denominator of the numerator and denominator of the denominator. So to do that, what I'm going to do, I'm going to do the common factor in the denominator, which is j omega. Now this value is going to be j square 4 omega square plus 6j omega plus 2, and here I have j omega in the denominator, and the numerator is j square 24 omega square plus j8 omega. Okay, it's very simple problem finding z total, but you need to have patience to solve the equations. Okay, so this j omega get cancel out. I will end up with j square is nothing but minus 24 omega square plus j8 omega over j square is nothing but negative 4 omega square plus j6 omega plus 2. Okay, that's the impedance zx parallel with zy. So my z total is nothing but, I have a real part 4 plus, and this value is 4 over j omega plus minus 24 omega square plus j8 omega over minus 4 omega square plus 2 plus j6 omega. I rearranged the denominator because as I mentioned, eliminate this j in the denominator, then only we can add we can separate the imaginary part. Okay, so what I'm going to do, I'm going to multiply and divide this equation by using the complex conjugate of the denominator. So minus 4 omega square plus 2 minus j6 omega over minus 4 omega square plus 2 minus j6 omega. Okay, so when it comes to the denominator, I have a square plus b square, which is minus 4 omega square plus 2 whole square, and b is j6 omega, so minus j square 36 omega square. Okay, and in the numerator I'm going to multiply it, but remember, I care for the imaginary parts but not for the real parts. Okay, so if it is a real part, I mean, don't waste your time calculating that value, but just put a placeholder. So what I'm saying, so here 24 omega square times 4 omega square, is it real part and imaginary part? It's a real part. Okay, so what I'm going to do, I'm going to put the placeholder. So here I'm going to put a placeholder, minus 24 omega square multiplied with minus 4 omega square. Okay, I'm not worried too much about it since it's a real part. Imaginary. Okay, now the next multiplication is minus 24 omega square plus 2, that is also a real part, so don't worry multiplying and finding the answer. Okay, now minus 24 omega square minus j, so for sure that is the imaginary part, so I'm going to write it down. So minus plus j 24 times 6, which is 144 omega cube. Okay, now I'm done with this. I'm good. Now I'm going to do the minus j8. So j8 omega minus 4 omega square, for sure that is imaginary part, so minus j 32 omega cube. Okay, plus j 16 omega, that's good. Now the last one is j8 omega minus j square, that's going to be imaginary, I mean that's going to be real part because it's going to be minus j square, so plus minus j6 omega and plus j8 omega. Okay, so whatever is there in the blue color, that's the imaginary part, right? Okay, so my z total equal to 4 plus 4 over j omega plus. Okay, so now I'm going to write down the imaginary part and real part. So 4 plus whatever is there, it's not the green color thing or green color part of the equation, that's real part. Now imaginary part, I have 4 over j omega. Okay, and here I have plus, so j 144 omega cube plus j 144 minus 32, which is 112 omega cube, plus j 16 omega divided by, here I might need to expand it, but I'm going to do it later in the next step, minus 4 omega square plus 2 whole square minus j square is nothing but plus 1 36 omega square. Okay, now what is the imaginary part here? This whole thing is the imaginary part. Now I'm going to make that as equal to 0. So when I make that equal to 0, 1 over or minus j over 4 plus j 112 omega cube plus 16 omega divided by this is omega minus 4 omega square plus 2 whole square plus 36 omega square equal to 0. When I make the imaginary part equal to 0, I told you this is no longer omega, this is going to be omega naught. Okay, now if I pull this part to the other side, it's going to be plus j, and j get cancelled out, so I'll end up with 112 omega naught cube plus 16 omega naught over minus 4 omega square plus 2 whole square plus 36 omega square equal to 4 over omega naught. Now I'm going to pull the omega naught to the other side. We'll end up with 112 omega naught whole to the power of 4 plus 16 omega naught square equal to 4 times. Now this is square, I'm going to expand that. That is 16 omega to the power of 4 plus 4 minus 16 omega square. When I expand that, that's what that value is, and I have plus 36 omega square. Okay, now I'm going to simplify this circuit, this equation, my apology, it's not circuit, it's mathematical equation. Okay, now I have 112 omega naught to the power of 4 plus 16 omega naught square equal to 64 omega naught to the power of 4 plus 16, so minus 16 omega naught square plus 36 omega naught square, that will be plus 16 times 4 plus 64 omega naught square. Okay, now I'm going to pull everything to the other side, so 112 omega naught to the power of 4 plus 16 omega naught square minus 64 omega naught to the power of 4 minus 64 omega naught square minus 16 equal to 0. So 112 minus 64, this is 64, that value is 48 omega naught to the power of 4. Okay, and the next one is plus 16 omega naught square minus 64, so that's going to be minus 48 omega naught square minus 16 equal to 0. Okay, what I'm going to do, I'm going to pull out the 16 here, and let me put omega naught square equal to some x. Okay, so it's going to be, if I pull the 16 out, okay, so 3 times x square minus 3 times x minus 1 equal to 0. So I have equation 3x square minus 3x minus 1 equal to 0. Now by using the quadratic equation function, find the x value. So after solving this quadratic equation, I end up with x value as 1.26 and x value as minus 0.263. Okay, so for sure x value won't be negative, so it must be positive value. Now x is nothing but omega naught square, so omega naught square must be equal to 1.26. So what is omega naught? Omega naught is nothing but square root of 1.26 radians per second. So this value is 1.122 radians per second. That is the angular frequency, resonant frequency, and f naught equal to 1 over, omega naught is nothing but 2 pi f naught. So f naught equal to omega naught over 2 pi. Okay, I will accept this answer in the exam. Okay, I will stop this video here. With this, I think we have enough examples on how to find the resonant frequency. Thank you.